And now for part C, which is Z3, C is Z3, and Z3 is given as -1 minus 5i. Step 1 is draw the Argand diagram, which carries a mark, by the way. It carries marks. This is the real part of the complex number Z3. This is the imaginary part of the complex number Z3. Then we need to indicate this. Do not waste your time marking points. Just go straight to the point or the value that you want. On the horizontal axis, which is the real axis, we need to indicate -1. So that means here I can have 1. On this side I will have here -1. On the vertical axis, which is the imaginary axis, we need to indicate -5. -5 is bigger than 1 in magnitude. That means just make it further away from the origin. This is +5. Then down here, further away is -5. It is therefore it to be reasonable, but it is not perfect. After indicating that, then you draw your complex number. The real part is -1. The imaginary part is -5. So on the real axis, this is -1. On the vertical axis, which is the imaginary axis, we have -5. So let's look for their point of intersection. You draw a line, then you draw the line. They are meeting somewhere here. So you draw a straight line from the origin to that point. Straight line from origin to that point. Then you put an arrow on it. Then say this is my Z3. Now, how do you get the argument? The argument is the angle that will run from the positive x-axis here up to where the complex number is. This is what we are calling the argument theta. Now, what do you notice? You notice that from here up to here is 180 degrees, right? So this one is 180 degrees. There is a music nearby. Hopefully, it will die down soon. So now for me, you already have 180 degrees. Now the only thing which is left is this side. This is the side which you don't know. This side is the side you don't know. So we need to come in. Here you have already 180 because this side is 90 and this side is 90. I'm trying my best to be slow. I don't know if I'm going fast. Now, how do we get this angle here? To find this angle here, we need to extract this triangle. This up to there. It's a right angle triangle, which will look in this format. We have that horizontal line. Then here we come down vertically straight. Here we come vertically straight. Then we have the complex now, which now runs in this format. That is the only thing that you extract. And now this is where the right angle falls for the triangle. Now, how do you get the distances? Remember, from here up to here is -1. Which you take as 1. Just take the number of units. Okay, these are distances and they cannot be negative, or the length cannot be negative. So from here up to here we have 1, and then from here up to down here we have -5. From here to down here is -5, but you take the value, it is a distance, so this side is 5. And then this is the angle that we are looking for, which I can call beta or alpha. Let me call it beta again. You call it anything. You can call it A, B, C, anything that can make you remember it. So this side is what we are calling now beta. So this is where the angle is. If this is where the angle is, this side facing it becomes the opposite to the angle. The longest side is always the hypotenuse. And then adjacent to the angle is the adjacent, which is 1. Now, if you look here, we have adjacent and we have the hypotenuse. And we have the opposite. We don't have the hypotenuse. So just come and write your SOHCAHTOA here. SOHCAHTOA. Then you come and check. What do you have? You have adjacent, which is 1, and opposite, which is 5. Adjacent and opposite together. So katoa, there is h here, then toa. So we are going to use tan because we have the opposite and adjacent. If you want to use sine or cos, that means you will first need to look for hypotenuse. After getting hypotenuse, then you can use sine or cos and you get the same answers. So just use tan because all its requirements are given. Therefore, here we shall now say therefore tan, we have chosen beta is opposite out of adjacent. And then we substitute. This is equal to what is the opposite? Opposite is 5 out of adjacent, which is 1. This is tan of beta. And then 5 divided by 1 is 5. So for us to get beta now, it becomes now the tan inverse of 5 divided by 1, which is 5. Tan inverse of 5, tan inverse of 5 is 78.69 degrees. Now you have seen that this angle beta alone, which is this small section here, is 78.69 degrees. Now, how do you get the argument? Now, the argument theta now becomes 78.69 degrees. Now, plus 90 and again plus 90, which is the same as plus 180. And now, this here gives us 78.69 plus 180 degrees, getting 258.69 degrees. 78.69 plus 180. Yes. Now, this is the angle that it makes to the positive x-axis. This answer is not wrong. It is correct. Even if it is not lying in the range of the principal argument, this answer is correct. So we can say argument of Z3 is 258.69 degrees. This is one answer. Now the other answer is, remember, when you are measuring from the positive x-axis, you can measure it anti-clockwise or clockwise. That means what we have done is anti-clockwise. Our calculations here have been under anti-clockwise. Anti-clockwise. If you leave this answer, it is correct. But in the concept of principal argument, we need to get the angle. It lies in this range. Remember, ours has gone to 258, and yet we want it between negative 180 and 180. So what do we do here? Now, here, just get, because remember, the complete revolution is 360. So we can just say 360 minus this answer. 360 minus 258.69. It's giving me 360 minus 256.69 is giving me 101.131. 101.131. That means if we are measuring it anti-clockwise, clockwise now, clockwise, it means the same argument Z3 would be negative. Remember, we said clockwise the angles are negative, anti-clockwise the angles are positive, 131 degrees. This is when we are coming anti-clockwise. And remember, I said the approaches to this concept are very many. You could start by getting this small angle here first, and then you add to 90, which is there, and then it will give you negative 101. Why are we putting negative here? Because we are measuring it from the positive x-axis through, but clockwise. Clockwise angles are negative. But if you are taking it anti-clockwise, it will be that positive. So whether you put this or this, they are correct. At this level, we cannot punish you for giving answers in either clockwise or anti-clockwise sense. So this is the solution to example 1 under argument of a complex number. Thank you.